Okay, let's practice more graphing lines, but this time on this sheet, notice that all of the equations are in our standard form. And that means ax plus by equals c. I can't remember if there, hopefully that's better. All right, standard form is ax plus by equals c. So again, notice the x and y terms have to be together on one side and the constant term has to be alone on the other side. So this is different from the sheet that we just did where everything was in y equals mx plus b form. So just to contrast it, y equals mx plus b. Here, the y was by itself, no coefficient because it's an implied 1. And everything else, the x term and the constant term were together on the other side. So here our formats are different and we're going to graph using this. Now again, in one of the other videos I showed you that you could always convert this into this form, but I really don't want you to do that on this one. We're going to do these three, problems 1, 2, and 4, using the other strategy that I showed you, which is we're just going to graph two very specific points. So let's take a look at this first one. It says 7x plus y equals 5. So again, we're noticing the x and y terms are together on one side and the constant is alone on the other. So what we're going to do in this case is we're going to plot 2 points, but 2 very special points. And the points that we're going to choose are the one that has the x coordinate 0, and then we find the y coordinate that goes along with that. And then the second one, it's going to have a y coordinate of 0, and we're going to have to figure out what the x one is. Okay, so what I usually do in this case, I'm going to do it the way I would want you to do it at first, and then I'll show you what I do. So 7, and then I'm going to put in the 0, so 7 times 0 plus y equals 5. All right, this is going to drop out. And when we do that, we just end up with y equals 5. Right, and then the second one, we're going to put 0 in for y, so 7x plus 0 equals 5. Again, this term just drops out, so we end up with 7x equals 5, and then x equals 5/7. That's really not very nice. This would be one case where maybe it would be worth it for us to switch it back into y equals mx plus b form, but we're not going to do that. Whoops, 5/7. All right, so 0, 5 is 1 point. And then 5/7, comma 0 is the other point. Now 5/7, if we were to talk about this in terms of about how big it is, 3.5/7 would be 1/2. So 5/7 is just a little bit more than half. So I'm going to put it right there. And then we'll just graph like this. Oops. Again, if you have any ruler, that would help getting these lines nice and neat. I do have one handy, so let me use that. Okay, so it would look something like this. Now again, when we get a line that's in this y equals mx plus b form, we can tell a lot from it just looking at it, like, you know, y equals negative 1/2 x plus 2. We can tell that this is going to have a negative slope, so it's going to be decreasing. We can tell where it's going to hit the y-intercept. We can't really do that with this form, right? There's not a lot of intuition that goes into that without doing some work to it, but just looking at that, I can't necessarily tell right off the bat that that's going to have that's going to be decreasing. With some practice, you'll be able to do that, but I would say that initially you're not going to be able to tell really quickly whether that's increasing or decreasing, and where the y-intercept is. It's just coincidental, or not coincidental, but this right here ends up being the y-intercept. It's just because this had a coefficient of 1. That won't always happen. Okay, so again, we pick x equals 0 and we find y, then we pick y equals 0 and figure out x, and we plot those 2 points. Okay, let's take a look at number 2. So again, we're just going to pick those 2 points, x, y, 0, 0. All right, so the first time we let x equals 0, this term just drops out. So we get 5y equals negative 5. Or y equals negative 1. All right, and then in the next case, we're going to let y equal 0, so we get 3x plus 5 times 0 equals negative 5. This term drops out, so we get 3x equals negative 5, or x equals negative 5/3. All right, then we go plot these ordered pairs, so 0, negative 1. And then this tells us negative 5/3, 0. That's negative 1 and 2/3. Because changing negative 5/3 into a mixed number would be 1 and 2/3 negative. So 1 and 2/3 would be about here, and it's on the negative side. And so we graph that. Again, this isn't going to be entirely accurate when we only use 2 points, which again, it helps to have more than 2 points, but in this case, just for ease of graphing, we just pick those 2 specific points. All right, now let me just say how I usually do this before we go on to the third one. So usually when I let x equals 0, I don't even rewrite it. I just cover up that x term because I know that when I plug 0 in there, it's going to cancel out and I get y equals 5. All right, here if I did the same thing, when I let x equals 0, that term is going to disappear, and so I just get 5y equals negative 5. And from there, I mentally just divide both sides by 5, and I get y equals negative 1. Right, when I let y equals 0, I still cover that up. I'm going to cover it up with my pencil, and then I get 7x equals 5. Sorry, I'm not sure if you can see that because of the shadow, but 7x equals 5, and then I solve that mentally, so I get x equals 5/7. And then when y equals 0 here, I get rid of that, and I get 3x equals negative 5, and I divide both sides by 3, and I get negative 5/3. So I've gotten really lazy over the years, and I don't even write that anymore. But while you're starting, I want you to do that. But as you get more confident, know that that term, when we put in the 0 for the x or the y, that term that contains the x or the y will just drop out, and you'll just be left with a very basic linear equation to solve. Okay, one last one, and then I'm going to let you do the rest on your own. We're going to do number 4. Number 4 says 6x plus 5y equals 20. So if I pick x and y, this is 0 in the first one, and y is 0 in the second one. All right, so in the first one, I'm going to let x equal 0. I'm going to use my strategy in this problem here. The 6 times 0 is just going to be 0, so that will drop out. So what I have here is 5y equals 20. When I divide both sides by 5, I'm going to get 4. So the y-intercept is 0, 4. And then I'm going to do the same thing for the y term when I let y equals 0. This term, the 5y, will drop out, and I'll end up with 6x equals 20. If I divide both sides by 6, I get 20/6, which reduces to 10/3. And this is equivalent to 3 1/3. All right, so then I plot them. So 0, 4, that takes me up to here. And then 3 1/3 is right about there. And then my graph. Okay. Now, notice in all of these, if you're trying to look for patterns so that again you have some intuition to see whether you did this properly or not, notice that every single term here, in this one and this one, both the coefficients and the constant, were positive, right? Positive, positive, positive. And we ended up with a positive y-intercept and a negative slope. Positive y-intercept, negative slope. All right, here we had positive, positive, negative. All right, we still ended up with a negative slope, but now we also got a negative y-intercept. So as you're going through and doing these, see if you can come up with some pattern that you realize works for all of these, that you can maybe get an idea of when you're going to get a positive or a negative slope. So if I were just to make a conjecture, or I would think a conjecture that you would make based on these three, when both of your coefficients are positive, your equation is going to have a negative slope, right? And then when they're both positive with a positive constant, you'll have a positive y-intercept with that negative slope, and here you'll have a negative y-intercept with a negative slope. So C, well, that one's still the same, but as you get to the next page, see what happens when you start getting negative coefficients with your x or your y. We just really have 8 and 9 where you can make a conjecture there. But see, does that negative coefficient change it so that you end up with a positive slope? What happens if both x and y had negative coefficients? Maybe you want to make up your own and see if you can come up with a possibility. Would it make a difference if you had a negative here and a negative here? All right, so just play around with that and see if you can come up with a pattern so that you can kind of guess or, you know, just verify that your equation looks like what you thought it would be. Okay, I'll see you in the next video.